Alright, so welcome everyone to lesson 04. In this lesson, we're going to talk about some interesting steps with the help of the enclosed object to simulate the behavior of the sack. Alright, so I have got this bag from the mud box and I have a little bit tweaked that up from the lens side, I guess, and I've also added some of the geometries over it to increase and to accentuate the further process and to give it the maximum reality as I can give. Okay, so what would be our next step? Of course, I'm gonna create the the polygon input geometry to the end cloth geometry. So under the end mesh, let's create an end cloth. So the moment I create that thing, obviously the end cloth object will gonna appear with the nucleus node, and if you're gonna select it up and go to the display and open up the shapes, you're gonna have the output cloth. Okay, so this is the cloth that basically drives all the simulations and all. Okay, so if we're gonna play that up, we're gonna see the the normal behavior of the end cloth, and we can also notice that this bag has just lost all its volume because there is just nothing inside it to preserve. So we need to address a couple of issues. There will going to be a lot of things involved in this lesson, so you're going to address some very cool, interesting tips to improve the simulations, since this bag is quite a heavy and we also have to deliver impact of dropping a heavy bag onto the floor, and by doing that the soft corners of the bag will obviously gonna get, it may good gonna get some interpenetrations. So we're also going to address that. Okay, but the first problem is for me just to hold the volume and as well as to provide the base to the cloth, since you can see that it is now is crossing the grid, since I haven't using any base geometry, or you can say the static object to hold, or the passive collision object to give a hold to the bag. So what I'm going to do is that, let's say open the attribute tab, and under the nucleus sections I'm going to use the use plane, the ground plane. Okay, and here I just want the plane frictions to be approximately 0.35 with a little bit of the stickiness. Many of the students used to ask me what exactly the difference between the friction and the stickiness. So, I also came to know about from the help files, the help data of the Maya. It clearly states that the stickiness is basically the property that is a force acting normal to the direction of the cloth, whereas this friction is acting a force in according to the tangent to the cloth. So you can say that the glue or the wood, when they act together, they show some sort of the stickiness. Okay, and when an object is basically colliding to the geometry, the force acting in a tangent way, it's trying to resisting it the motion to bring the kinetic force down to the potential. Okay, so it's very going to be important thing. And of course, to improvise the further quality of our simulations, we obviously had to, rely upon the substeps. My key tool, my key attribute inside the whole chapter should be the substeps, because without this, we can't improvise the quality of the end cloth. Okay. So let me just begin with that by saying 15 will gonna be the best value, since I've already experiment on the subject of substeps attribute, and finally I came to know that 15 will going to be the most stable value, or you may could say the value of 12 to 15 should be the most stable value for giving the best results to falling back. Again, the max collision iteration also should set that thing to the 15. And with respect to that, just go to the enclosed shape node, and down under here something called max self collide iterations. I also gonna need to increase them from 4 to, let's say, 8, or may could be 10 also. Okay, and later on you're gonna see the important changes we're gonna have in this simulation with the help of these key attributes. Okay, fine. Now coming back again, like we discussed in the previous lesson also about the space scale, here I also want to use that to 0.1. But one little issue is that, even with the 0.1 also, the bag will not going to fall in that realistic way as it needs to fall. So what I can do is that instead of letting it to further down to 0.010, I would like to increase the magnitude of the gravity. By taking that subject to 30 with the magnitude, I obviously gonna act more downward force for the bag to get fall down quickly and to stable quickly. Okay, so let's just do one thing. First of all, let's just play the timeline and see what do we have got. Again, there is no preservation of the volume, but you can see that this is just, I should say, let me just press 3 over here to get rid of such uh, black areas. Obviously, this is going to be a dirty cloth, I should say, and just play the timelines for more. As you can see, just trying to get itself settled by not getting overlapped. But again, I'm not going to like that thing. So, of course, taking that thing to back, and now, first of all, coming back to the enclosed shape node, let's say the thickness should be 0.1. It's really going to be useful if you're going to use the collision object, because the thickness of this will obviously going to collide up with the geometry. So I need to give it some reasonable value. And let's just do one thing. Under the solver display, let's open the self collision. Here, in case I'm using the vertex mode, which will gonna drive the simulations of the cloth and help them in protecting and adhering the collision. So the collision will going to take place with the help of the cloth, with the help of the vertices only. So let's just do one thing. We're going to increase the self collide width scale to approximately 4.5. I guess that should be fine. It shouldn't need to be too much. Okay, you don't need to cover up the whole area. So set that thing to off. Again, I'm going to use a little bit of bounce so that the chances of getting the cloth penetrating inside the object also should be less, because the bounce will also going to release the cloth instead of allowing it to settle upon itself and allowing it to get penetrate. And again, the friction is also very, very important. So let's leave it to 0.1. We could give some thickness, but here I don't need to give it. And of course, with the stretch resistance, let's say we give that thing to 50 as a start, compression again 50, bend 50, by leaving bend angle drop off to 0. Okay, and coming back to the shear resistance, let's give that thing to 50 once again. Okay, and here in case the rigidity is very going to be very important, so let's do one thing. We're going to give 0.15 value to it, because this cloth is really going to be a heavy cloth, and let's say we are imagining that this is made up of the jute or maybe some another stuff which is quite heavier than a cotton or a normal piece of cloth. So rigidity is really going to be important, and it obviously going to allow the cloth not to get compressed. Okay, let's just do one thing. Instead of going ahead, let's just now take a quick play. Obviously the speed will going to be reduced, and oh my god, it's really gonna be too much of flexing. Okay, so I'm not gonna play it further. Okay, it's really gonna be a joke. Okay, so what we gonna do next to improve that kind of funny simulations, of course, so that's just because of the rigidity, because if you don't give the rigidity, you could see some another funny moments again. First of all, the volume is also going to be get affected, and here you can see that, oh my god, this is really going to be you can clearly notice what is going on. So let's just do one thing. Rigidity should be set that thing to 0.0150, and along with that, now the deform resistance will gonna allow the cloth to get less deformed when it can when it's gonna receive the hit from the ground. So here in case I'm going to use a fairly high value, approximately 3.5, or may could be higher also, depending upon the simulation set we're going to get. Okay, and of course I'm going to bring down the lift to 0, drag to 0. I don't want any parallel perpendicular forces acting upon the cloth. And the most important attribute here we're going to be the damp as well as the stretch damp, because I also want my code to get settled fast. Since it's going to be a heavier object, so can't expect that thing to be into the motion for a longer frame. So let's just put that thing to 4, I guess, and stretch damp, set that thing to the 10. Rest is, I don't need to tweak anything, because there are going to be many attributes here, but we don't generally need them. But as I've got the idea from my experience that if in the case the cloth will gonna get itself get penetrated. So you may could utilize this option of the trap check along with some push out radius and things like that. But here in this case, we will not gonna need any of them. Okay, so I can just switch some of the quality settings, and I guess I should go for a play, and I'm gonna play that stuff for the next lesson. Okay, so see you in the next lesson.